All right, so I know it's been a while because you guys had a long weekend and I wasn't here yesterday, but on Thursday we were talking about multiplicities of x-intercepts, like how many times a factor goes in evenly into a polynomial, and based on that multiplicity you can kind of determine what the graph looks like at that x-intercept. So can we just for a second maybe revisit that idea? Can someone describe perhaps if an x-intercept has a multiplicity of 1, what does the graph look like at that spot? Or maybe if you're familiar with a multiplicity of 2 or 3, what the graph looks like? Can we revisit those connections? Yeah?
If it has a multiplicity of 1, it goes straight through the graph. If it has a multiplicity of 2, it just like touches
Okay.
the x-axis. If it has a multiplicity of 3, it kind of like straightens off and goes up.
Levels off. Perfect. Okay, so multiplicity of 1, it goes straight through the x-axis, kind of like what's going on right here. Notice how it just goes straight through. And then if it has a multiplicity of 2, it just bounces or touches the x-axis, kind of like what's going on at this spot. And then if it has a multiplicity of 3, it also goes through the x-axis, but it goes through kind of level. You kind of flatten off a little bit. We don't really have an example of that on here, but at least you could kind of visualize that in your head. So we're going to continue looking at x-intercepts today and relating the x-intercepts to their multiplicities, but we're going to take a look at more of a number approach, like analyzing numbers, not necessarily a graph, to give us that picture. So let's kind of see how this goes today. We're going to consider this polynomial, okay, this equation, and we've looked at this one before. I think this graph showed up before. We're going to find each pair of function values below, and we're going to use them to help us answer some of these questions. So let's first off go ahead and find h of -2 and h of -1. What are those notations telling us to do? What do they mean? Do you instinctively feel like doing something when you see those? Go, Tori. Plug them in. All right, so if you have a calculator available, you can go ahead and use it. Maybe some of you can do it in your head, but we're going to go ahead and plug in -2 and see what we get, and we're going to plug in -1 and see what we get. Maybe when you get done with those two, you can do the other values in the second box. How does -9 and 4 sound for the first box? Good? And then 3 and 7 for the second? Perfect. All right, so let's take a look at these numbers. From the graph, which we have, we clearly know that there's an x-intercept or a 0 between -2 and 1. Okay, we can see that graphically. But how do the numbers that we described over here kind of confirm that idea? Notice how we were using an x value of -2 and -1, like that number and that number. Graphically, we know that there's an x-intercept, but how can you confirm that based off of these numbers you found? Yeah. Say it again? There's a sign change. If you go from negative to positive or positive to negative, what number do you have to go through eventually? If you think about a number line. Tori's saying it, right? 0. That's why an x-intercept is kind of referred to as a 0. An x-intercept always has a y value of 0. So if you go from a negative to a positive or vice versa, you know you have to go through 0 at some spot. Okay, so maybe we'll make note of that. Since there is a sign change in the y values, there must be an x-intercept between the x values. Okay, specifically between -2 and -1, those numbers we plugged in. Does that make sense? If you go from negative to positive, positive to negative, that means you had to cross 0 at some spot, right? All right, now here's the tricky thing. Take a look at the next question. Does the same reasoning we just described hold true for the x-intercept that we know is between 0 and 2? Notice how on the graph between 0 and 2 there's another x-intercept. Can we still use the same reasoning? This time we're looking at the second box over here. Notice how 0 and 2 were the x values we plugged in. Do we have that sign change? No. Okay, so here's what's a little tricky. Just because there is no sign change doesn't mean that there's not an x-intercept. Okay, it just means you're not going through the x-axis. Okay, so there may be an x-intercept in here. Maybe there's not one. Okay, we're not sure. We're not guaranteed to have one there. But at least we know that there's a possibility. Okay, and specifically, notice how if there's no sign change, you kind of have that multiplicity of 2 because you're just bouncing. Okay, you're going back in the direction that you were traveling before. So we'll say no, since there is no sign change, we are not guaranteed an x-intercept. Even though one might exist. That's kind of the kicker. So moral of the story, if you have a sign change, there definitely is one, but if there is not a sign change, we're not sure. There may or may not be. Do those make sense based off the graph and the number values we found? Okay, so what we're going to do is we're going to utilize those two connections, whether we have a sign change and whether we don't, to kind of determine the multiplicity, perhaps, of an x-intercept. So let's say that we do have a sign change. So we'll say if there is a sign change in the x or y values, then there is an x-intercept between the x values with a multiplicity of what? Okay, so you know there's an x-intercept. You know you're either touching or crossing the x-axis. Can you think of what the multiplicity might be? If you think about multiplicity of 1, multiplicity of 2, multiplicity of 3, and what they look like on a graph, if you have a sign change, what type of multiplicity might you have? Yeah. 1. Okay, because we said multiplicity of 1 goes straight through the x-axis. Okay, that means you're going from above to below the x-axis, right? You're going from positive to negative or negative to positive, some type of sign change. So that's a possibility. Is there another one? Is there another multiplicity that somehow goes through the x-axis? Yeah? 3, right. The multiplicity of 3 goes through. It's level, okay, at the x-axis, but it still goes through. So if we have a sign change, we know we have either a multiplicity of 1 or 3, because we're going through the x-axis. Okay, let's go ahead and talk about the other one. If there is no sign change, an x-intercept might exist with a multiplicity of 2. Yep. 2 is the bouncing one. So you're not going through the x-axis, which means you don't have that sign change. Okay, and then there's that phrasing again, might exist. We don't know. But if it does exist, we know it has a multiplicity of 2. All right, so we're going to utilize these relationships or connections to help us perhaps find some x-intercepts when we have a table of values given to us, maybe not necessarily a graph, because a graph is kind of easy. You can just look at the x-axis and see what's happening. Table of values, not so much, because we just have specific numbers, not a whole graph. So if we take a look at the table, they tell us the table of value below represents a quartic function. So we have an x to the 4th polynomial. And then they go on to say we have a negative root, meaning a negative x-intercept. And then we have 3 positive roots. Okay, so 3 positive x-intercepts. So if you think about a graph, we know we have 1 x-intercept somewhere on the left, and then 3 other ones on the right. One's negative, 3 are positive. So let's take a look at the table to help us answer some of these questions. Are any of the roots or x-intercepts specifically identified in the table? So based off those numbers, can you give me an x-intercept, or more than one perhaps? What do you think, Rebecca?
1 is x-intercept.
Okay, notice how when you have an x value of 1, your y value is 0. Okay, signifying you are on the x-axis. You have a height of 0. So we'll say the ordered pair 1, 0 is an x-intercept because the y value is 0. Perfect. So now that we know it's an x-intercept, perhaps we can figure out what the multiplicity is. Okay, what does the graph look like at that spot? So what is the multiplicity of this 0? Explain your reasoning. What do you think?
Well, there has to be a multiplicity of 1 since there are 4 points and it's a quartic function.
Okay.
So since it has one negative root and three positive roots, like, they can only have a multiplicity of 1 to add up to a multiplicity of 4, which will give you the quartic function.
That makes sense. I wonder if this was a typo. So what Rebecca's saying is, since we have 4 x-intercepts, I think one of the connections we talked about last week is how if you add up all the multiplicities, that's the degree of your polynomial, right? So if you have 4 x-intercepts and your degree is 4, that means each one of them has to be 1, right, to add them up. But there's something else that's weird going on in the table. I wonder if this should have said 2 positive x-intercepts. I'll have to look into that. So I understand where you're coming from with those, but is there something going on in the table that might signify something different? What do you see, Hannah? It could be 2. If you take a look at a point before the x-intercept and after the x-intercept, do you notice how they're both negative? Right? So what's probably happening is, at this x value of 1, if you're negative before it and you're negative after it, notice how that's kind of making that bouncing or just touching motion, which would signify a multiplicity of 2, right? So I can understand where Rebecca's coming from. Based off the table, it seems like it'd be a multiplicity of 2. Let's see. We're going to write down the multiplicity of 2, but I'm going to look into that, Rebecca, see what was going on, okay? But that was a really good observation. Let's go ahead and say, since the points before and after the x-intercept are negative, there is no sign change. So it's a multiplicity of 2. All right, let's try the next one. Between which 2 x values in the table is the negative root located? So we're trying to figure out, where is this negative x-intercept? Can you look at the table to perhaps think about where that one might show up? What do you think, Tori? How do you know? Okay, so these are the only negative values in here. It could have been perhaps between -1 and 0, because those are still negative values. But what Tori was mostly looking for right there was that sign change. Notice how we go from some positive number to some negative y value, okay, which is signifying we're going from above to below the x-axis. So we'd have to cross it at some point. So we'll say there is an x-intercept between -4 and -1. Since there is a sign change in the y values, aka the heights, you go from 40 to a -8. Do we know what the multiplicity is of that specific root or x-intercept, whatever it might be? Can we say for sure if it's a 1 or a 3? Yeah?
Well, it has to be one because of the other one.
Because of the other ones, yeah. Okay, so this is when Rebecca's kind of analysis there of a quartic function. It would have to be 1, because if we already know this one is a 2, there's no way this one could be a 3, right? Because we know they'd have to add up to 4. So that's one way you could determine that. Without a specific graph, though, we would have to need a little bit more information. But since you know it's quartic, you know it would have to be a 1. So there's an x-intercept. Since the y-values change sign, with a multiplicity of 1. We doing okay so far? These make sense? No graph anymore, we're just looking at a table. Alright, last one. Between which two x values in the table is the second positive root located? Explain your reasoning. Yeah. Between 3 and 5. How'd you know? There's a sign change. Yep, we go from negative to positive. So there is an x-intercept between 3 and 5. Since there is a sign change, in the y values, can we figure out the multiplicity of this one? Yeah. It would have to be 1, yep. So we had a multiplicity of 2, and then a 1, and then the only other option would have to be 1 because we know they have to add up to 4. Okay? Hanging in there? Pretty good? Alright. Well, that's it for this section on multiplicities. I think we're pretty good with the idea, either looking at a graph or looking at a table. I know yesterday you had a lot of time to work on some homework from this section or the other sections, but you still have quite a bit of time left today to do that. So if you want to continue to work on some of the homework problems, you can. You can ask me some questions if you need help. Yes, do we want to go over some?
I just had a question.
Question, I'll come over in a second, okay? All right, so free response day tomorrow, partner quiz on Thursday, okay?